Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and this is one of such events. If you want to find out more about the events we have, there is a link in the description. Go there, click on this link, and you'll see all the events we have in our schedule. Then, if you haven't subscribed to our YouTube channel, do it now. You will not regret. We have a lot of amazing videos, and you will not miss any of them if you subscribe. And finally, last but not least, don't forget that we have an amazing Slack community. If for some reasons you're not there yet, you're missing out, join to hang out with other data enthusiasts. The link is also in the description. During today's interview, you can ask any question you want. There is a pinned link in the live chat. Please use this link, and I'll be covering these questions during the interview. Also, you might notice that there is a poll right now in the live chat, which asks, what's your role? So please take a moment to answer this question. And now I will stop sharing my screen. And what I will do is I will stop the poll. How do I actually do this? Okay, I'm trying to figure out the interface and poll.
We broke your workflow.
Yeah, but I don't do this often. So we have 21 vote. So engineer scientist, the individual contributor, is 85%, not working yet 9%, manager 4%, and director is how many do you think?
1. 4%, 1.
No, 0.
0. All right.
Yeah.
So I guess this would be very, very helpful. With my team, I always like to, even with the individual contributors, every time we speak and do our sessions, kind of give an outlook of what your job could look like as you progress, as you grow, as it's going to be the next, and really understand how organizations work. And I think that could be helpful for everybody, even in individual contributor role.
Okay, so should we start? Okay, let's roll. So this week we'll talk about building data science practice, and we have a special guest today, Andrey. Andrey is a director of engineering at Honeywell, where he leads the advanced technology group within the safety and sensing business. He is working on developing technologies and solutions based on signal processing, perception, computer vision, AI, machine learning for healthcare, industrial, logistical, market verticals. So that's you're doing quite a lot of work. And you've been with Honeywell for 5 years, right? And Andrey also lives his wife and son in Dallas, Texas. So it's a pleasure to have you here, Andrey.
Thanks, Alexei. It's a pleasure to be here. I hope we'll have a great session here.
Yeah, we definitely will. Before we go into our main topic of building data science practice, let's start with your background. Can you tell us about your career journey so far?
Sure. So, like you say, I'm director of engineering at Honeywell. I lead and support what's called the Advanced Technology Group, which is sort of like a composition of several teams. We are working on novel technologies that we later introduce into our product line. So we work with a lot of signal processing, like you said, perception, vision. And across in the last 5 years, I worked across supported multiple organizations. I came to lead our AI adoption initiative, and later transferred to build our robotics group, where I led our perception team for a year. So it's been a good journey of working through multiple advanced teams and building maturity and building practice into those teams. In terms of my career, I've been coding since I remember myself, probably seven years old, and I've been always kind of engineer at my heart. But my formal background is actually not the computer science. My formal background is organizational development management in the context of IT and technology organizations. I have a scholarship and multiple degrees in organization development and management. overall, I started as a software engineer, and I used, I saved my paycheck on the side to fund a few businesses. Some of them that I successfully failed, and some of them were later acquired. And during one of those businesses, so I was there as a technical co-founder. We did that business was around. We were actually scanning and digitizing retailer catalogs for coupons. It was back in Europe, and we were essentially scanning those coupon printed paper catalogs, and we were extracting the information from those catalogs, and we were kind of offering that on our website. And that required a lot of, first of all, image analysis, and also sort of recommendation models. And this is where that was 2014, 2013, 14. This is where I fell in love with data science. And starting then, this is where I really started my journey with data science, with conventional data science, data analytics, and then later into the neural networks, of course. And that led me, it was interesting because, after I had my own sort of set of businesses, I went to another extreme. I went to Honeywell, and Honeywell, in Europe and the Middle East, it might not be as well known in US. Honeywell is a Fortune 100 company with a 100-year-old history and heritage, being known for mostly, before it was well known mostly for industrial hardware, industrial equipment. And some of you might ask, what brought you from doing your own startups into multinational conglomerate with 100,000 people. But I joined Honeywell 5 years ago when the company got its new CEO, who put the company on the trajectory of digital transformation. It's really what it meant, moving company from being hardware oriented into more software industrial oriented, essentially changing our model from selling one-time hardware to selling services and subscription that is enabled by that hardware. And that meant really, sensorizing, connecting all of that equipment, pushing data into the cloud, and doing a lot of analytics, doing a lot of signal processing, doing a lot of intelligence in the cloud that you can actually multiply the value of those solutions. And that really sold me on that. I realized that would be a lot of scope of doing analytics, doing AI, and we could be really at the beginning of it. And so that really sold me on my role. And it's just everything that we work here is really high impact. That you are in your everyday job impacting millions of customers. And so I work with over my last 5 years, I worked in with logistics, warehouse robotics. I worked with smart cameras or some cool technologies for sensing. And most of what we do is vision and perception. But we also worked into other modalities like natural language and voice and predictive analytics overall.
So I'm just wondering, what kind of industrial equipment do you work with? Is it like conveyor belts or things like that?
So this is one of the product lines. And Honeywell is a really distributed organization. You can think of it's actually like a Russian doll, where you have like things like you have 5 big business groups at the top: aerospace, smart connected buildings, performance materials, safety products, our own cloud platform. So it's 5 big companies within the umbrella of one company, and then each of those companies they split into their own businesses and units, and it's a very complex structure of businesses and portfolios that you need to navigate.
That's a very interesting name. I would assume that they do like cereals, breakfast, because the name is tasty.
No,
Honeywell.
that
But yeah, it's
that
quite
was the
the
first thing
opposite.
that I thought. But in US, company well known for, well, every building, mostly almost every building has some sort of Honeywell product. Every
Mhm.
commercial building, and I bought a house last year. I found a gas meter from Honeywell, and the Honeywell thermostat. So like when I try to sell Honeywell to the engineers and managers that I hire, I usually talk about that, which is true, that essentially, anywhere you go in a building, the airplane, car, you would find, even, space shuttles, you would find something from Honeywell.
And you developed some things for these gas meters, for things on airplanes, or only, like, I guess, for these assembly lines, right? You're working
Well,
on
you use
improving that.
so I work in the business group, which is called Safety and Productivity Solutions, and there are things like, again, smart cameras, smart sensors, robotics for warehouses. You go to Starbucks or you go to IKEA, you would see at the barcode scanner at the post terminal will be from Honeywell. So it's really, in your daily, you wouldn't notice it, but really you touch Honeywell product on a daily basis.
Yeah, quite interesting. Okay, I know nothing about this company up until now, so that's you're doing quite a lot of interesting stuff. And um, yeah, so the topic today is building data science practice. But I was wondering, so what does it actually mean, data science practice? Is it a data science team, or there is more to that?
Well, when I think about practice, I think about sort of like a widespread adoption of best data science and machine learning engineering practices across the organization. And it might not seem something special in the context of small organizations where you have just one product team. But when you think about multi-product team organizations that are distributed, it's not a straightforward thing to make data science work efficiently. And really, it's about breaking organizational barriers, not allowing for silos. You don't really have a way to, if you want really to your data science strategy run efficiently, especially in the very beginning, you cannot allow for teams using multiple frameworks or using multiple tools or using multiple clouds, and really it's that makes things inefficient. And so this is what I think when I talk about the data science practice. It's aligning everybody on the same page, so teams work not only efficiently within the team context, but also within the organizational context. And yeah, so it's just maturing up the organization and to shift from ad hoc, like pilot, where teams constantly are building pilots, but they don't push those pilots into production. And that's how to shift from the sort of constant pilot stage to mature stage when you ship and you productize.
Mhm. And I'm wondering, in your particular case at Honeywell, so Honeywell to me strikes it strikes me as a more like traditional company where IT comes second, AI comes second, while there are companies like internet companies where it's much easier
Right.
to get data and start using machine learning. Like for you, I guess that was an extra layer of challenges, right?
Exactly. And that was when I was talking about, that when I started 5 years ago, and the company took a turn of saying, we are no longer going to be focused just on the hardware. And with hardware, you can think of, you build the hardware, you sell it let's say a gas meter, you sell it one time, and then you maybe support it, you maintain it. There's a software component. But this is like sort of like 5 years ago, the company turned and said, we're going to be doing a lot more software now. And essentially where this is the complexity of integrating of data workflows and algorithms that are based on data come in place. And so really, it was such an honor of being a part of putting the company on a trajectory of change. And I won't say that, first of all, I won't say that everything went perfectly well. We learn from we learn from our mistakes, but it's also always it's a very difficult thing to make a shift like that in a company with a 100-year-old history and 100,000 people. It's humongous effort. And this is where you make sure that you learn there's so much complexity here that you learn really fast.
And I'm really curious now that you mentioned, this is not what I was going to ask initially, but now that you mentioned that a gas meter, you just sell it and support it.
Right.
And there is no way you can include software. So can you actually include software into a gas meter? Or it's just,
Right. Well, you have, of course, like a long tail. You have products that are more conventional and less intelligent, but you just start building intelligence into them. Well, I can a better example would be, for example, we started working on some advanced sensors for the quality of the air, for example. And before I worked on this problem, I really, I didn't think that was such a problem. Well, you're breathing air, right? I mean, how could that be dangerous? But then when we started actually looking at it in the microscope, what are the different things that we are breathing in, like mold and pollen and pet dander and dust, you got really scared. What you're really breathing in, or things like when you buy a house and you realize that I had a cat allergy. And I realized when I moved in that there was a cat living here, and we had to do a deep cleaning here. But so we, for example, building a sensor that with the push of a button can tell you all the micro allergens that are in the air. And so what you're actually getting from making those things connected is, first of all, you now can process the data in the cloud, and you can run massive signal processing and the analysis on the data that you process. And you're able not only run the workflows and workloads in the cloud, but you can actually get this data and fine-tune your model, of course. And so that allows you to really build in the algorithms that you wouldn't be able to literally otherwise you would need a whole computer with a an industrial GPU on it, and that this device would cost like several $1,000s and things like that.
You cannot put it physically in a gas meter, right?
Yep, exactly.
So coming back to data science practice. So you mentioned that a data science practice is a set of data science and machine learning practices, or like how do you spread the adoption of these practices, right? And then you mentioned like not having silos, having the same tools and processes in different teams. Right. And sounds like a very good thing to have. And I'm wondering, I'm joining a company as a data science, I don't know, as the first data scientist, I don't know, data science manager or maybe director or just as a data scientist. And we want to build it. So how do we build these data science practices, and what are the steps to get there?
Right. So here, of course, I might say it depends, but it really depends on multiple factors. I won't say there is just I sort of have like a mental model of going from low maturity to high maturity, or like I say, you crawl, you walk, and then you run. A lot depends on the size of the organization, of course. A lot depends on whether where you would want to, what would be the focus. So where are you going to deliver the value, and or in other words, actually the first major and if, when you're interviewing with a company, where you're working in a company, it's good to reflect on who in the organizational hierarchy the data science team is reporting into. And actually, I never asked myself when think questions like this when I was just an individual contributor, but it's hugely important, and it's important because depending on to which executive the data function rolls into, this data group could actually do very different things. And the example would be, so if the data function rolls into the CTO, or the chief technical officer, that would most probably mean that the data group will be focused on enhancing the product capabilities, right? So CTO is responsible for building an offering or building a product, right? So if you are reporting to CTO, that means that your function goals would be to enhance the capability of the actual product that you work on. But this is not the only thing, because you could also, for example, report into CIO, Chief Information Officer, and in this case, very likely you would be working a lot on the internal optimization workflows, like optimization of efficiencies of your internal ecosystem instead of working on the product. Or the data team could report into Chief Marketing Officer, and then it would mean that it's mostly analytics function around marketing and sales and customer interaction. And so that's an interesting question to reflect on. Because really whoever you report into, that means that the goals of that particular executive you will be helping to achieve. And so when it's probably the step zero to really reflect on this and say, okay, where the data can provide the biggest value. And it does not necessarily need to be either or. There are organizations that report into the CEO, and then in this case, it would really mean, if you report into CEO, most likely it would mean that you will work across all of those functions. So the data will have their own place, both in product engineering, both in internal optimization, both with sales and marketing and customer interaction. But this is very important question to reflect, because that would really define what kind of what is the profile of the talent that you will be working with. What are the profile of algorithms that you will be working with? The example is, so we work on product, and the modality of the algorithms that we work is mostly signal processing and computer vision. This is because we work a lot with sensing aspect of our work. But then we also have a team in Honeywell that works on optimization of internal processes, like demand prediction, for example. And that team doesn't do any computer vision. That team only works with essentially, fairly conventional predictive analytics algorithm. There is nothing wrong about it, but it's just a different type of algorithms that you will be working on. And so it's good to actually understand, because that question, that answer would align you what kind of talent, what kind of algorithms, what kind of technology and the infrastructure that you will have to build in order to fulfill those goals. I hope it makes sense.
Yeah, it does. I'm just wondering, so the company where I work, it's called Toilix. We're doing its online marketplace. When I joined the company, the data function, or I don't know how to call it, like my manager was reporting to a CPO, Chief Product Officer. In this case, I think it's a similar idea, like reporting to a CTO. So improving the product, right? But here in this case, product has its own, I don't know, vertical, or how to call it. And I guess in case if you report directly to CEO, it makes you a chief data officer in this case.
No, it could be
not yet.
And some organization call it formally chief data officer. It could be it could be still VP of VP of data, or yes, right. But reporting to CEO mean that you would it's that you would not only have a focus on engineering, or you would not only have a focus on internal IT and things like that. So your function will go much broader, and it's really about who is going to be your executive sponsor, well, and which. And your executive sponsor is going to lead and assign particular goals and particular initiatives for you. So it's hugely important. But as we go through this, and you talk, so you ask about sort of like the steps, right? But my mental model is that you go through low maturity, medium maturity, and high maturity. And the low maturity would mean that you come into the team and you start building a team that usually, it depends on the, who drives that. There are situations when the executives drive that, and they would hire senior roles, and sort of like the initiative of developing this practice would come from the executive level. But many times the initiative of building data into products or internal capabilities would come from engineers themselves, right? And I've been there myself. When I came to Honeywell, we had sort of similar situation. Some of the initiatives that we were building really came from the software engineers who at some point of time got inspired by data, and they started working with machine learning algorithms or other conventional data algorithms. Or another approach would be engineering managers would think of additional capabilities, and they would start hiring data scientists, and thinking that you can just hire a data scientist, plug them into the team, and then overnight, magic will happen, and overnight the products will get some magic intelligence, artificial intelligence type
a lot of profit
functionality.
Right?
Yes, but it doesn't happen this way. And data science or artificial intelligence, it's a very multi or cross-functional type of stacks. And this is one of the misconceptions, where you can just hire a PhD and overnight you'll get the benefit. And I think many organizations underestimate the complexity of it, because it really impacts the talent that you have. And there's more than just data scientists, right? And we can talk about this. There are more research scientists, there are machine learning engineers, there are data engineers. There are impact into the infrastructure, and there is impact into how you run processes. There is an impact in the whole mindset shift, where going from a sort of pre-planned waterfall type of approach to engineering into more iterative engineering. And so there are those things that you don't really, many people sometimes from the conventional software background, they don't know about. And this is why there is just high expectation, and this is why things take so much long time than originally assumed.
I'm just curious, in your opinion, what is what happens more often, that it comes from the engineers, from the bottom-up approach, or more like executive decides, they listen to some consultants from McKinsey and decide to build this practice? What does happen more often?
Yeah, I don't have that being data driven, I don't have those stats. But I think it's sort
anecdotally.
Right. I think it's a combination of that. I see both of those situations the same way, like you're talking about, both McKinsey consultants, but CEOs and CTOs. We are not talking about something that came just yesterday, right? The data science got popularized. I think the peak was roughly around 4 years ago, when it was really at the peak. Right now, everybody knows about it almost. But also, I see a lot of engineers who software engineers with conventional backgrounds that because AI becomes such a hot topic, that and there is so much of democratization. The tools that we have right now, when you can like the example with Stable Diffusion, when you can just download a Google Colab notebook, run a few cells, and you would have the whole thing in front of you. And I think many people just really feel very empowered by that, and want to get excited and overexcited sometimes about it. And this is something I really often try to watch out for, both for myself and for my team, because if you get overexcited about something, you sometimes get really biased, and instead of really working through what's important for the customer, you start working on something just because you want to try this technology, and AI becomes not a solution for some customer problem, but it becomes a shiny things that nobody knows. So when you think about integrating data science workflow, building up data science capabilities, you really need to start from how can I really improve my customer experience, instead of, hey, I have this shiny technology, hey, let's find where we can where we can plug this technology into.
Yeah, I've
And
been
I think
there,
so many people just get
done that.
super
Yeah.
biased about this.
Speaking of Stable Diffusion, so this is indeed super cool. So the other day I played with this and generated a data set with dragons and dinosaurs. So to me, they always looked the same, and I thought, okay, maybe we can just get some data with dinosaurs and dragons, and then it's still like the pictures are creepy still, but sometimes they're really good. Okay, coming back to this building the practice. Right. So let's say we join a company and we figure out that we report to, like which executive we report to, like the options, as you mentioned, CTO, CMO, CIO, CEO. All of them, right? So what happens next? Like, what do we do next? So we figure out that, let's say it's a CTO. Well, what's next?
Yeah, so usually you get to really understand, and the way it usually works is that the right thing, of course, is understand what kind of problems we want to solve with data, or what kind of capabilities we want to build with that. But it doesn't always work like this. As I said, there are some grassroots efforts, bottom up, when engineers start coming up with new ideas right there, and start building some proof of concepts. And usually the first stage is what I call crawl stage, right? Before you walk, you got to crawl. This is where teams start to kind of build those proof of concepts. And usually it's with a company that still has not built a mature data practice. This is the really big challenge, is to move some of those proof of concepts into production. Because again, the expectation is, hey, let's just hire a PhD data scientist. They will just build a model, bum, bum, bum. There we go. We'll have this new magic functionality. But again, it doesn't work like this. But this is what exactly the situation when I came to Honeywell 5 years ago, when we had some data scientists here and there. They were hired by conventional software engineering managers who didn't know anything about the data. And so the expectation was that we're just going to hire them, plug them, and they will start working on them. But it's more than that. And first of all, it's really about the fact that it's very easy to build flashy proof of concept demos, but it's very difficult to get them into the production, because, as you know, well, first of all, building a model is on a small data set. For the flashy demo, you can probably get some data points that you can build a model. But really, to make it a robust model, you got to have a different level of volume of your data set. And that's always a problem. Where are we're going to get the data? And unfortunately, the companies that are not as mature, they don't prioritize collecting data early enough, and which has to be really prioritized right there when you actually build a project passport, right? At the step 0, when you're thinking about the project, or you're thinking about the feature or function that you're going to integrate into the existing project, you gotta start thinking, where are we going to get the data on top of which we are going to build our model? And companies don't prioritize that. So to build initial model, it takes some time, but it takes 10x more time too. And then many other reasons that really things like the engineering component of building data products is different from conventional software engineering. And just by building a model, you cannot enable the feature, right? You need to integrate this model. You need to deploy this model. You need to watch and operationalize this model. You need to be able to have the closed loop of retraining this model based on the new data that is coming in. And so usually this is not how conventional software engineering works. So you really need to change the processes, change the infrastructure. And so that takes time. And so this is why often you have a hard time really to deploying those demos. And I've been myself wrong many times on this, and this is exactly how I started myself. But you reflect on all of those issues, and you start fixing them by one. And so in this crawl stage, in the beginning stage, I'm not a big fan of having many different projects and seeing what actually works out, because you have multiple teams, and when you have multiple teams and multiple scientists and engineers, and it's more difficult to manage them. My approach is having a fewer projects as possible on which you can build the whole end-to-end process. And so in the scroll stage, the idea is usually just get one project out of the door end-to-end. One project that would become sort of like a poster child, an example for the full cycle of collecting data, running experiments, identifying which model is the best, changing the infrastructure, and having the roles of people who would work on the infrastructure to be able to productize those models, monitor those models, retrain those models, and essentially having a whole end-to-end cycle. And this is where, I would say, put the major focus on having at least one project that is successful, instead of having 10 projects that fail. Because if you have 10 projects that fail, what happens is that data science gets a bad reputation, and people get actually a lot more negative about building data-enabled products. So I would here put most of my eggs in one basket and running end-to-end. And this is where you switch into the next phase of data maturity, and you build a centralized practice. That means you want to now get all the efforts and all the scientists in one organization, and really start building when working on further.
You mean projects, like a team, right? Organization.
Right. And in early stages, it's good to collect all of them in one team or all in one organization and centralize them. And what I mean by that is that you need to build a set of best practices, and you need within one team. What makes it easier, that if all of those people under one team, it's easier to popularize those best practices and integrate and deploy those best practices. And what I mean by best practices, it starts with talent acquisitions and hiring, of understanding what are the actual roles, what are the difference between research scientist, machine learning engineer, data engineer, data quality engineer, and other professions. And really understanding what the difference between those, having actually job descriptions for those, because when you start actually HR, you come to HR and they don't know what, who do we need to hire? And when you hire wrong people, everything is wrong after that. It starts from aligning on a particular set of infrastructure and tools, right? So which cloud are we going to be using? Are we going to be using cloud? Are we going to be using on-prem? Are we going to be using our own deployments? What kind of tools we're going to be using? Are we going to write our own experiment tracking system, or we're going to be using, other tools on the markets from Weights and Biases, Neptune, Comet, and so on and so forth? How we're going to be productizing and deploying those models, and things like that. So when you are within one team, it's a lot easier to and faster to build those best practices, and really align the team on those best practices. But the trick is the centralized approach is actually it's how I think, and it's really subjective. It's not the best way of managing data organizations, but it's the step that you have to go through, on the way to higher maturity. So in a way, you start with ad hoc approach where you build one major proof of concept. You go to a centralized model where you get the team together and you build set of practices by working on more projects. But this is not the most efficient way of running data teams, in most cases, just because when you have a centralized team, and let's say a product manager comes to you and say, hey, we need to build this, let's say, a recommendation engine for our website. Can you give us, a data scientist? And so you have a list of projects that you work on as a centralized team, and then you need to market your team internally, so product managers or engineering managers come to you, and you act sort of like a resource pool. But then it doesn't work most efficient, because there is a queue. Essentially, you need to prioritize those projects. And how do you prioritize those projects, right? But also, you get a data scientist or machine learning engineer or data engineer that today they work on one project and tomorrow they work on a different project, and so they don't really work with consistently with one team. They not necessarily know how people or how those teams operate and act, right? They don't establish trust and respect with those teams. And what I also found out, through a lot of mistakes and hard experiences, that when you have a centralized team, your scientists, their performance is treated by their own scope. And it's going to get clearer now. But if you actually push that scientist and actually right there into the team, and having that scientist actually report into that team and be formally a part of that team, the performance of that scientist is going to be treated more like based on the performance of the whole project, right? So on one side, you have a centralized team, and performance of the scientist is rated on the performance of their work. But if they work for a particular team, a report for a particular engineering manager, for example, their performance is more going to be treated as a performance of overall project, which you actually want. You don't want your engineers and scientists only to say, hey, this is my type of work. This is only what I'm responsible for. I don't care about anything else. You actually want them to be, drivers and the fans of the project itself, and think like the project success fully relies on them. And so this is where the third model comes in.
Just that's a lot of information, and I want to try to summarize everything you said before we move to the what you call run phase.
Decentralized.
Right?
Yep.
Decentralized. Yeah. So first, we need to figure out who is our executive sponsor, right? And then that it also helps us to understand which problems to solve with data, what kind of things we work on, and then we start with a proof of concept. Not many proof of concepts. It's better to select a single one, as few as possible, let's say a single one, but we need to make sure that it is successful at the end, right? So we don't want to fail, because if we fail, then data science gets bad reputation, and then we might lose trust of our executive sponsor who was rooting for us, right? So we don't want to do that. So because the executive sponsor really believed in us. So we need to try to meet the expectations, right? And then, so we do this POC, and this POC, you mentioned that it often comes from engineers who want to do something cool, and then they pitch it to, I don't know, the managers, and then this thing starts. And then eventually we have a POC, and then it goes to the next phase, which is, I don't know, we see that we don't have, we don't have any
approach. Yep.
Yeah. We don't have any data, right? We need to build all these pipelines, and then we need to productionize the model. And we do this centrally because we want to make sure that we build this set of practices that you mentioned. And then I think it's important to understand what kind of roles we need, what kind of tools we want to use, right? And all these things that you just talked about. But then centralized approach creates problems, right? Because you act as a resource pool, and then sometimes there are not enough resources in the pool. So then we need to, and all these other problems you mentioned that I don't remember, but like there were a big list, right? Which brings us to the next phase, the embedded teams, right? Decentralized teams, where a data scientist, decentralized teams, where a data scientist or data person sits in the team, right? And then this is where I stopped you.
And when you say when it sits, the importance is who they report into. They can still work on those projects, but the problem is, the question is, who do they report to? Do they report into, let's say, the organization of chief data officer, who is kind of a central, or they report to the engineering manager of that particular product? And it's a big difference, because your manager is the one who rates your performance. And so in this case, it's better that usually, and you actually you move from a centralized model by taking all those people who used to be in your centralized model in your own team, and then you say you're now going to report to this engineering manager, and you're going to be working for that product or that function. And it's not that it might sound like something difficult or heartbreaking, right? You used to report to one manager, and now you report to a different manager. But really, in my experience, many times it actually came very naturally, because as people work with different teams, they create some affinity and some experience towards particular problems or particular teams or particular business domains. And it's when you transition from this centralized to decentralized, it's actually much easier approach, because many times people will say, yes, I want to work for that product right now. And so that doesn't create as many frictions. And this is what we went through. We used to have one centralized team, and then we said, for example, you used to work on this particular set of problems for this particular business, for this particular product line. You are now going to report to that engineering manager, and you're going to be working with them. And you essentially spread your team across, and you have them work on a particular project, and
what
that helps them.
Do you just kick back and don't do anything?
Oh, no. Well, this is why I say when decentralized models, they're not. I've never seen fully decentralized models work ideally, and usually what I call semi-decentralized. So you still have to leave some space. You still need to have one central function that will be responsible for some of the functions, because, like, for example, the hiring, or the infrastructure, some of those things have to be still central. But the engineering, for example, engineering teams and product engineering teams, it's better than they work with their engineering managers and their product teams. And so there is still some level of, sometimes this model is called hub and spoke, meaning that there is one hub, you still have a chief data officer that's responsible for some of the high level functions and standards, but then you have different team across the organizations, and that work almost autonomously. You still build bridges between them. You still kind of work with them to understand what kind of problems they have, what kind of roadmaps they work on. But what's really important, I think, that it's you have to have the right set of steps, and you have to go first to centralized and then decentralized. And the reason for that, when you are centralized, you need to build that set of practices, and then those people take those practices to their own teams. And they don't start from zero when they start when they are product teams. And this is hugely important. And
your role, I guess, is still trying to make sure that or making sure that they have this common set of practices. Now they are spread, and that they might come up with their own thing, which is fine, right? But you don't want to like, you still want to maintain the same set of tools, the same set of practices. It's not
there are
like
still some things, and it's not always the same. Like, it doesn't mean that everybody needs to have to use PyTorch, right? There's still, you know, some will use PyTorch and some will use Tensor. But I'll give you a good example. Vendor relationships, right? When you work with tools and procurement of tools, when you work, you know, central function is much more efficient in identifying which tools we want to procure for those teams to use, rather than having those teams actually decide what tools they because you don't want to have, let's say, like different vendors for the same things in different groups. Again, it's not that black and white, but usually this is how it works more efficiently. So you as a central function, knowing what kind of problems your teams are dealing, you can say, hey, how about we're using, you know, I don't know, this particular experiment tracking or MLOps platform. And then, because this is the way you can actually get the best deal, and then you can help those teams consume those products. So this is one of the examples that work very well. Or like with data annotation or image annotation, we do a lot of image annotation. You know, what vendor are we going to be using for data annotation, right? Things like that. So there are still some functions in the central org that is more efficient to be solved.
Yeah, we have quite a bunch of questions and not so much time, so probably we should go to the questions and try to answer them. And the first question was, which book would you recommend to learn more about building a data science practice? Are there books like that at all?
I have I could probably can I post a few suggestions in the LinkedIn post to this event?
Of course.
There are quite a few. I read a lot on this. I got some book that I read some time ago that I wanted to recommend, which was that was fairly amazing. I'll have a hard time right now to quickly identify it.
Yeah, we can include the links in the description later when you will find it.
I promise to get back to you.
Yeah, okay. Okay, another question from Adonis. You mentioned that software engineers pivot into data science. And how do they actually convince their manager to do this?
It's actually, so it's a good question. If you are a software engineer, you want to pivot into data science. I have actually a long post on LinkedIn about this, but my advice is always about this is it would be very hard for you to get hired as a data scientist from scratch if your previous position is a software engineer. So my advice to you is try to convert into the data scientist at the same company you're currently working at. So you get actually formally data scientist title, and you work through and get some experience in it, get a few years of experience, and then you can either stay in this company or switch and get hired into another company with a formal role of data scientist. Now, what you can get transferred is really, you know, it's all about finding right problems to solve and really solving them. And if you can come and you know, and offer, let's say you're building, I don't know, a product recommendation algorithm, and you know, your team doesn't have an experience with it, and you can really in your free time dive into the subject, get, you know, build a prototype, gather the data, build a prototype, and really show to your team that you can build a mature model. It's not going to be easy, but it will take some time. It's not that your engineering manager, you know, just because you are a software engineer, they will say no. Sometimes they will say, but it's about being actually persisted in offering yourself as a problem solver for data heavy problems, and within your organizations, moving to teams that have more data. So think about from the perspective, where do I have the data? And what are the problems that I can solve with that data? And the teams that have abundance of data usually have problems that you can solve with this data.
That does it usually happen at the POC stage, the centralized stage, or decentralized stage, or does it even matter?
It does not. The more the more mature the organization is, the harder it would be to really switch. But it's not that you won't be able to switch. So it's I have a few examples on people who were software engineers, actually just were persistent and helping solve hard problems using data. And then at some point of time, you come to your manager and say, hey, I've been essentially a data scientist for the last 2 years. Can we work with you for me to formally change the title? We had use cases like this.
Mm-hmm. Yeah, we actually also had use cases like that in the company where I work. A person was a data engineer, and then he said, okay, look, I'm actually doing ML engineering for the last 2 years.
Right.
Can we
exactly
make the switch formally?
Exactly.
Then I guess at the POC stage, it's the simplest, right? So just, okay, there's this cool thing, let us try. And then this thing works, and all of a sudden, 1 year later, you're just doing this thing.
Right. But if you're a software engineer, you will most likely underestimate the complexity of it.
Yeah.
You might build, again, a model that works for the demo, but really integrating it in a robust way. There is a long way from a demo to a robust model. And you will probably underestimate that. So it's not weeks and it's not months from that level. Yeah.
So another question we have is, what is your favorite data science practice so far? Like, I guess we talked about all these best practices. No, like, what do you think is the most important one to have?
Practice as a interesting question. I mean, I think what's most impactful is, and where many people are making mistakes is really that if you hire a PhD scientist, you should not rely on what they make to productionalize, because you should not rely that the code that they write in a Jupyter notebook could be transferred into production. For this, you will need another stage of machine learning engineer and or applied data scientists who would then recrunch all of that code and put it into production. And I think many organizations, many people, or many managers with a conventional background, they don't understand that. There is actually, these are the two extremes of developing a model and having that model run in production. And you have to put in place other roles to ensure that you can make this code robust to productize it.
Yeah, it's probably not like the best practice, but more like realization and a way to set expectations that, look, if we hire this person who has a PhD in machine learning, it doesn't mean that we automatically get rich tomorrow, right? So managing these expectations and then saying that, okay, we actually need a team of engineers to make it work. That would be your answer, right?
So that essentially comes down to having clear roles, that there is a research scientist, and distinguishing research scientist from machine learning engineer. I can tell you one example. I know we're running out of time, but I used to work with PhD research scientists, and every time I come with a problem to them, they say, let me go and read white papers. And many times you don't need to read white papers. There is this solution up front for you that you can do. But I see a heavy reliance on, hey, let me go and I'm going to go for 2 weeks and I'm going to read white papers before I'll give you a solution. And this is what I clearly is like research scientist mindset that does not work well when you productize anything. it's great to have them, but it's you have to plug additional roles in order to transition to production.
Okay. Well, before we finish today, do you want to, maybe you wanted to mention something but didn't have a chance?
Oh, well, we talked about so much already. I hope it resonated, and I know we had a lot of scientists and engineers in the audience. Again, my advice would be, if you want to grow, you need to think from the perspective of the higher you go in your seniority, the more impact you have across the stack, across the team, across the business, across the organization. And so my advice is, spend some little amount of time of learning of what actually happens just beyond of your scope of your role. That will propel you faster to the next level. And again, the people are promoted not because they will learn the skills they will require at the next level. They are promoted because they already exercise the skills that need to be at the next level. So this is why, be more forth-looking into what are other teams or roles are doing, and be more open about how do I make a broader scope type of impact beyond what just I'm currently working on. And thanks for this chat. I hope that was interesting.
So, am I right that the best way to reach out to you is LinkedIn?
LinkedIn would be the best. Yeah, I'm fairly active on LinkedIn, so please do connect.
Okay, thanks for joining us today. Thanks for sharing all your expertise, experience with us. And also thank you everyone for joining us, for asking questions, for being active. I see that there is a long discussion in live chat. So yeah, thanks for joining us today, and everyone have a great weekend.